Partha world presents laws of chemical combination based on class 11 syllabus. Chemical reactions take place according to certain laws called as the laws of chemical combination. There are 5 general laws of chemical combination. They are the law of conservation of mass, the law of constant composition, the law of multiple proportion, the law of reciprocal proportion, and the law of combining volumes or Gay-Lussac's law. The first 4 laws deals with the mass relationship, whereas the fifth deals with the volume of the reacting gases. First law, law of conservation of mass or law of indestructibility of matter. Law of conservation of mass was first propounded by Antoine Lavoisier in 1774 based on the data he obtained after carefully studying numerous combustion reactions, and it deals with the relation between the mass of the reactant and the products. This law states that matter can neither be created nor be destroyed during any physical or chemical changes, or the total mass of the reactants before the reaction is equal to the total mass of products after the reaction. If the reactants are presented by capital R and the products are presented by capital P respectively, then as per this law, R1 plus R2 plus R3 till Rn is equal to P1 plus P2 plus P3 till Pn, where R1 plus R2 plus R3 till Rn are the masses of the reactants and P1 plus P2 plus P3 till Pn are the masses of the products. To prove this law of conservation of mass, Hans Landau's devised an S-shaped glass apparatus known as Landau's tube. Landau took known weights of sodium chloride solution in one limb of the Landau's tube and silver nitrate solution in the another limb. Then he mixed the two solutions by inverting the tube and found that the final weight of the product formed was same as the weight of the solutions taken. Numerical problems based on law of conservation of mass. Example 1. When 6.25 gram of calamine was heated, 2.2 gram of carbon dioxide was released. Find the weight of the residue left if the reaction follows the law of conservation of mass. Here, the total mass of reactant is equal to the weight of calamine, that is equal to 6.25 gram. Let us assume that the weight of the residue is x gram. Then the total mass of product is equal to the weight of residue plus carbon dioxide, that is equal to x plus 2.2 gram. Since the total mass of the reactant is equal to the total mass of products, therefore x plus 2.2 gram is equal to 6.25 gram. Solving for x is equal to 6.25 minus 2.2 gram, that is equal to 4.05 gram. Shortcut method: R is equal to P1 plus P2, that is equal to 6.25 is equal to P1 plus 2.2 gram. Solving for P1, that is equal to 6.25 minus 2.2 or 4.05 gram. Example 2. In one experiment, 170 gram of sodium nitrate was heated, but the reaction was stopped after some time. It was found that the amount of oxygen formed was 16 gram and the weight of sodium nitrate was 69 gram. Find the weight of undecomposed sodium nitrate. Solution: the total mass of reactant is equal to weight of sodium nitrate, that is equal to 170 gram. Let us assume the weight of undecomposed sodium nitrate be x gram. Total mass of products is equal to weight of undecomposed sodium nitrate plus sodium nitrate formed plus oxygen formed, that is equal to x plus 69 gram plus 16 gram. Since the total mass of reactant is equal to the total mass of products, therefore 170 is equal to x plus 69 plus 16. Solving for x is equal to 170 minus 85, or x is equal to 85 gram. Shortcut method. Here R is equal to P1 plus P2 plus P3, that is equal to 170 is equal to P1 plus 69 plus 16. Solving for P1, P1 is equal to 170 minus 85 is equal to 85 gram. Example 3. When 168 gram of lime was reacted with 196 gram of phosphoric acid, 54 gram of water was released. Find the weight of calcium phosphate thus formed in the reaction. Solution. Let us assume the weight of calcium phosphate formed be x gram. Total mass of reactant is equal to weight of lime plus weight of phosphoric acid, that is equal to 168 plus 196 gram, that is equal to 364 gram. Total mass of product is equal to weight of calcium phosphate and water formed, that is equal to x plus 54. Since the total mass of reactant is equal to the total mass of products, so 168 plus 196 is equal to x plus 54. Solving for x is equal to 364 minus 54, that is equal to 310 gram. Shortcut method. R1 plus R2 is equal to P1 plus P2. 168 plus 196 is equal to P1 plus 54, that is equal to P1 is equal to 164 minus 54 is equal to 310 gram. Example 4. When 73 gram of hydrochloric acid was reacted with caustic potash, 185 gram of solution was obtained. Assuming the caustic potash is of pure quality, find the weight of caustic potash required. Answer. Let us assume the weight of caustic potash required be x gram. Total mass of reactant is equal to total mass of hydrochloric acid plus caustic potash, that is equal to 73 gram plus x gram. Total mass of product is equal to mass of the solution formed, that is equal to 185 gram. Since the total mass of the reactant is equal to the total mass of the product, so x plus 73 is equal to 185. Solving for x is equal to 185 minus 73, or x is equal to 112 gram. Shortcut method. Here R1 plus R2 is equal to P1, that is equal to solution. Solving for R2, 73 plus R2 is equal to 185, or R2 is equal to 112 gram. Example 5. 0.66 gram of a hydrocarbon on complete combustion with oxygen gave 1.32 gram of carbon dioxide and 2.7 gram of water. Show that these results agree with the law of conservation of mass. Here, the molecular mass of carbon dioxide is equal to 44 units. So 44 gram of carbon dioxide contains carbon 12 gram. That means 132 gram of carbon dioxide will contain carbon 1.32 into 12 divided by 44, that is equal to 0.36 gram. Molecular weight of water is equal to 18 units, or 18 gram of water contains hydrogen is equal to 2 gram. 2.7 gram of water contains hydrogen. 2.7 into 2 divided by 18, that is equal to 0.30 gram. So the total weight of carbon and hydrogen after the reaction is equal to 0.36 plus 0.30 gram, that is equal to 0.66 gram. Thus the total weight of carbon and hydrogen before and after the reaction remains same. Hence the law of conservation of mass is validated. Second law, law of definite proportion or law of constant composition. The law of constant proportion was given by Joseph Proust in 1797. This law states that a pure chemical substance, regardless of its source, is always made up of the same elements combined in a fixed or constant or definite proportion or ratio by weight. In simple words, if we get pure water sourced either from rain or a drain, it will always have the composition of hydrogen and oxygen combined in the ratio of 1:8 by mass respectively. Numerical problems based on law of definite proportion or law of constant composition. Example 1. Weight of CuO obtained by treating 2.16 gram of metallic copper with HNO3 and subsequent ignition was 2.7 gram. In another experiment, 1.15 gram of CuO on reduction yielded 0.92 gram of copper. Show that the results illustrate the law of constant composition. Here, in experiment 1, mass of copper oxide is equal to 2.7 gram and mass of copper is equal to 2.16 gram. So, the mass of oxygen is equal to 2.7 minus 2.16 is equal to 0.54 gram. Now, the ratio of mass of copper and oxygen is equal to 2.16 is to 0.54, that is equal to 4:1. In the second experiment, mass of CuO is equal to 1.15 gram. Mass of Cu is equal to 0.92 gram. So, mass of oxygen is equal to 1.15 minus 0.92 is equal to 0.23 gram. Ratio of mass of Cu and oxygen is equal to 0.92 minus 0.23, that is also equal to 4:1. Since the ratio of copper and oxygen in both the experiments are same, it illustrates the law of constant composition. Now there can be shortcut method for solving this question. In the first experiment, 2.7 minus 2.16 is equal to 0.54. Ratio of 2.16 is to 0.54, that is equal to 4:1. In the second experiment, 1.15 minus 0.92 is equal to 0.23. Ratio of copper is to oxygen is equal to 0.92 is to 0.23, that is equal to 4:1. Example 2. 0.7 gram of iron combines directly with 0.4 gram of sulfur to yield iron sulfide. In another experiment, 2.8 gram of iron were dissolved in dilute sulfuric acid and excess of sodium sulfide solution was added. 4.4 gram of iron sulfide were precipitated. Show that the above figures illustrate the law of constant composition. Here, in the first experiment, mass of iron is equal to 0.7 gram. Mass of sulfur is equal to 0.4 gram. So, the ratio of mass of iron and sulfur is equal to 0.7 is to 0.4, that is equal to 7:4. In the second experiment, mass of iron is equal to 2.8 gram. Mass of sulfur is equal to mass of iron sulfide minus mass of iron, that is equal to 4.4 minus 2.8, that is equal to 1.6 gram. Ratio of mass of iron and sulfur is equal to 2.8 is to 1.6, that is also equal to 7:4. Since the ratio of iron and sulfur in both the experiments are same, it illustrates the law of constant composition. Shortcut method. In the first experiment, iron is equal to 0.7, sulfur is equal to 0.4, ratio of iron is to sulfur is equal to 7:4. In the second experiment, iron is equal to 2.8, sulfur is equal to 1.6. So ratio of iron and sulfur is equal to 2.8 is to 1.6 is equal to 7:4. Example 3. Common salt obtained from Sambar Lake contained 60.79% of chlorine, whereas 3.2 gram of sample obtained from seawater contained 1.95 gram of chlorine. Show that these results illustrate the law of constant composition. First case, percentage of chlorine is equal to 60.79%. Percentage of sodium is equal to 100 minus 60.79, that is equal to 39.21%. So ratio of percentage of sodium is to chlorine is equal to 39.21 is to 60.79, that is equal to 2 is to 3. In the second case, mass of sodium chloride is equal to 3.2 gram and mass of chlorine is equal to 1.95 gram. Mass of sodium is equal to mass of sodium chloride minus mass of chlorine, that is equal to 3.2 minus 1.95, that is equal to 1.25 gram. Ratio of mass of sodium is to chlorine is equal to 1.25 is to 1.95, that is also equivalent to 2 is to 3. Since the ratio of sodium and chlorine in both the experiments are same, it illustrates the law of constant composition. Shortcut method: sodium is to chlorine is equal to 100 minus 60.79 is to 60.79, that is equal to 39.21 is to 60.79, that is equal to 2.3. In the second experiment, sodium is to chlorine is equal to 1.25 is to 1.95 is equal to 2 is to 3. Example 4. Illustrate the law of definite proportion from the following data. 0.32 gram of sulfur on burning in air produced 224 ml of sulfur dioxide and NTP, and SO2 obtained by decomposition of sulfate contains 50% sulfur. Solution: molecular weight of sulfur is equal to 32 plus 32 is equal to 64 units. 22,400 ml of sulfur dioxide and NTP weigh 64 gram. So 224 ml of sulfur dioxide and NTP will weigh 0.64 gram. In the first experiment, 0.64 gram of sulfur dioxide contains sulfur 0.32 gram. So the oxygen content is equal to 0.64 minus 0.32, that is equal to 0.32 gram. Ratio of sulfur and oxygen is equal to 0.32 is to 0.32 is equal to 1 is to 1. In the second experiment, percentage of sulfur given is equal to 50%, so percentage of oxygen is also equal to 50%. So ratio of sulfur is to oxygen is equal to 50 is to 50, that also comes as 1 is to 1. Since the ratio of sulfur and oxygen in both the experiments are same, it illustrates the law of constant composition. Example 5. Carbon dioxide obtained from heating of marble contain 32 gram of oxygen for every 12 gram of carbon in it, whereas the same gas released during the exhalation process of respiration contained 27.3% of carbon. Show that these results illustrate the law of constant composition. Solution: in the first case, 12 gram of carbon combines with oxygen is equal to 32 gram. So the ratio of carbon and oxygen is equal to 12 is to 32, that is equal to 3 is to 8. In the second case, percentage of carbon given is 27.3%. So the percentage of oxygen is equal to 100 minus 27.3, that is equal to 72.7%. Here the ratio of carbon is to oxygen is equal to 27.3 is to 72.7, that is equal to 3.8. Since the ratio of carbon and oxygen in both the experiments are same, it illustrates the law of constant composition. Third law, law of multiple proportion. This law was given by John Dalton. This law states that when two elements combine to form two or more compounds, the weight of one of the element which combine with the fixed weight of the other bear a simple whole number ratio. Numerical problems based on law of multiple proportion. Example 1. Hydrogen and oxygen are known to form two compounds. The hydrogen content of the two compounds is 42.9% and 27.3% respectively. Show that this data agrees with the law of multiple proportion. Solution: first compound, percentage of hydrogen is equal to 42.9% and percentage of oxygen is equal to 100 minus 42.9, that is equal to 57.1%. That means 57.1 gram of oxygen combines with hydrogen 42.9 gram. So 1 gram of oxygen will combine with hydrogen 42.9 divided by 57.1, that is equal to 0.75. In the second compound, percentage of hydrogen is equal to 27.3%. So percentage of oxygen is equal to 100 minus 27.3, that is equal to 72.7%, or 72.7 gram of oxygen combines with hydrogen is equal to 27.3. That means 1 gram of oxygen combines with hydrogen is equal to 27.3 divided by 72.7, that is equal to 0.35. The ratio of weights of hydrogen which combines with the fixed weight of oxygen in both the compound is equal to 0.75 is to 0.375, that is equal to 2:1, which bears a simple whole number ratio. Thus, this data agrees with the law of multiple proportion. Shortcut method. First compound, percentage of element A is equal to A% and percentage of element B is equal to 100 minus A, that is equal to B%. Ratio is equal to A is to B is equal to X. Second compound, percent of A is equal to C and percentage of B is equal to 100 minus C, that is equal to D%. So ratio of C is to D is equal to Y. X is to Y should be a simple whole number ratio. Example 2. If a certain oxide of nitrogen weighing 11 gram yields 5.6 liters of nitrogen at NTP and another oxide of nitrogen weighing 15 gram yields the same volume of oxygen at NTP, show that this data supports the law of multiple proportion. First compound, 11 gram compound gives nitrogen 5.6 liters. So weight of nitrogen is equal to 28 divided by 22.4 into 5.6, that is equal to 7 gram. Weight of oxygen is equal to 11 minus 7, that is equal to 4 gram. So 1 gram oxygen combines with nitrogen is equal to 7 divided by 4, that is equal to 1.75 gram. In the second compound, 15 gram of compound gives oxygen 5.6 liters. So the weight of oxygen is equal to 32 divided by 22.4 into 5.6, that is equal to 8 gram. Weight of nitrogen is equal to 15 minus 8 is equal to 7 gram. So 1 gram oxygen combines with nitrogen is equal to 7 divided by 8 is equal to 0.875 gram. The ratio of weights of nitrogen which combines with the fixed weight of oxygen in both the compounds is 1.75 is to 0.875, that is equal to 2:1, which is a simple whole number ratio. Thus the data agrees with the law of multiple proportion. Shortcut method. First compound, percent of A is same is A%, percent of B is equal to B%, the ratio is equal to A is to B, let us take it as A. Second compound, percent of A as C, percent of B as D, the ratio is equal to C is to D, that is equal to, let us take as Y%, X is to Y, bears a simple whole number ratio. Example 3. A metal forms two oxides. One oxide contains 46.67% of the metal and the other 63.94% of the metal. Show that this data agrees with the law of multiple proportion. First compound, percentage of the metal is equal to 46.67%. So percentage of oxygen is equal to 100 minus 46.67, that is equal to 53.33%. 53.33 gram of oxygen combined with the metal 46.67 gram. So 1 gram of the oxygen combined with iron is equal to 46.67 divided by 53.33 is equal to 0.875. In the second compound, percentage of the metal is equal to 63.94 percentage. So percentage of oxygen is equal to 100 minus 63.94, that is equal to 36.06 percentage. That means 36.06 gram of combined with the metal 63.94. So 1 gram of the oxygen combines with the metal 63.94 divided by 36.06, that is equal to 1.773. Since the ratio of weights of the metal which combines with the fixed weight of oxygen in both the compounds is 0.875 is to 1.773, that is approximately equal to 1 is to 2, which bears a simple whole number ratio. Thus, this data agrees with the law of multiple proportion. Shortcut method. First compound, percentage of metal is equal to 46.67 percentage. Percentage of oxygen is equal to 100 minus 46.67, that is equal to 53.33 percentage. So ratio is equal to 46.67 divided by 53.33 is equal to 0.875. In the second compound, percentage of metal is equal to 63.94 percentage. Percentage of oxygen is equal to 100 minus 63.94, that is equal to 36.06 percentage. So ratio is equal to 63.94 divided by 36.06, that is equal to 1.773. Since the ratio 0.875 is to 1.773 is approximately equal to 1 is to 2, this data agrees with the law of multiple proportion. Example 4. The oxide of iron on analysis gave the following results. A 0.72 gram of ferrous oxide contained 0.56 gram of iron. B 1.6 gram of ferrous oxide contained 1.12 gram of iron. Use the data to illustrate the truth of law of multiple proportion. Solution. First compound, weight of ferrous oxide is equal to 0.72 gram. Weight of iron is equal to 0.56 gram. Weight of oxygen is equal to 0.72 minus 0.56 is equal to 0.16 gram. 0.16 gram of oxygen combines with iron is equal to 0.56 gram. So 1 gram of oxygen combines with iron is equal to 0.56 divided by 0.16 is equal to 3.5. In the second compound, weight of ferrous oxide is equal to 1.6 gram. Weight of iron is equal to 1.12 gram. Weight of oxygen is equal to 1.6 minus 1.12, that is equal to 0.48 gram. 0.48 gram of oxygen combines with iron 1.12 gram. 1 gram of oxygen combines with iron is equal to 1.12 divided by 0.48 is equal to 2.33. The ratio of weights of iron which combined with the fixed weight of oxygen in both the compound is 3.5 is to 2.33, that is equal to 3 is to 2, which bears a simple whole number ratio. Thus, this data agrees with the law of multiple proportion. Shortcut method. First compound, weight of FeO 0.72 gram, weight of Fe 0.56 gram. Weight of oxygen is 0.72 minus 0.56, that is equal to 0.16 gram. So ratio is equal to 0.56 is to 0.16, that is equal to 3.5. In the second compound, weight of the compound is 1.6 gram. Weight of the iron is equal to 1.12 gram. So weight of oxygen is equal to 1.6 minus 1.12, that is equal to 0.48 gram. Ratio is equal to 1.12 divided by 0.48 is equal to 2.33. Ratio of 3:5 and 2.33 is approximately equal to 3:2. Thus, this data agrees with the law of multiple proportion. Example 5. Sulfur and oxygen are known to form two compounds. The sulfur content in one of these compounds is 50% while in other is 40%. Show that this data agrees with the law of multiple proportion. Solution. Here in the first compound the percentage of sulfur given is 50%. So the percentage of oxygen is also 50%. That is 50 gram of sulfur combines with oxygen 50 gram. So 1 gram of sulfur combines with oxygen is equal to 1 gram. In the second compound, percentage of sulfur is 40%. So the percentage of oxygen will be 60%. That is 40 gram of sulfur combines with oxygen is equal to 60 gram. So 1 gram of sulfur combines with oxygen is equal to 60 divided by 40 is equal to 1.5 gram. The ratio of the weights of oxygen which combine with the fixed weight of sulfur in both the compound is 1:1.5, that is equal to 2:3, which is a simple whole number ratio. Thus, this data agrees with the law of multiple proportion. Now shortcut method. In the very first compound, we take the ratio of sulfur is to oxygen, that is 50:50, that is 1:1. In the second compound, the ratio of sulfur is to oxygen is equal to 4:6, that is equal to 2:3. The ratio of weights of oxygen which combined with the fixed weight of sulfur in both the compounds is 2:3, which bears a simple whole number ratio. Thus, this data agrees with the law of multiple proportion. Fourth law, law of reciprocal proportion or law of equivalent proportion. This law was first formulated by Jeremias Richer in 1791. This law states that when two elements A and B separately combine with the same weight of the third element, the ratio in which they do so will be the same or some simple multiple of the ratio in which A and B directly combine with each other. Numerical problems based on law of equivalent proportion. Example 1. Phosphorus trichloride PCl3 contains 22.57% of phosphorus. Phosphine PH3 contains 91.18% of phosphorus, while hydrochloric acid HCl contains 97.23% of chlorine. Prove by calculations that it supports the law of reciprocal proportions. Solution. In phosphorus trichloride, percentage of phosphorus is equal to 22.57%. Percent of chlorine is equal to 77.43%. So, 1 gram of phosphorus combines chlorine 77.43 divided by 22.57, that is equal to 3.43 gram. In phosphine, percentage of phosphorus is equal to 91.18. Percentage of hydrogen is equal to 8.82%. So 1 gram of phosphorus combined with hydrogen is equal to 91.18 divided by 8.82, that is equal to 0.0967 gram. Here we have to understand this. The two compounds, we have to take the common element and we have to get how much of that particular element is combining with the other two elements. That two elements are the constituent of the third element. Now here we are making the phosphorus constant, or we are considering how much gram chlorine or hydrogen is combining with particular fixed amount of 1 gram of phosphorus. Now the ratio of weights of hydrogen and chlorine in phosphorus trichloride and phosphine is equal to 0.0967 is to 3.43, that is equal to 1 is to 35.47. In hydrogen chloride, percentage of hydrogen is equal to 2.77 percentage. Percentage of chlorine is equal to 97.23 percentage. Ratio of hydrogen and chlorine is equal to 2.77 is to 97.23 is equal to 1 is to 35.10. Ratio of weights of hydrogen and chlorine bear a simple ratio. that is equal to 1 is to 35.47 divided by 1 is to 35.1, that is equal to 1 is to 1. So the data agrees with the law of reciprocal proportion. Shortcut method. First we make 3 columns. In the first column we write the first compound PCl3, in the second column we write PH3, in the third column we write HCl. Now HCl has hydrogen chlorine. Now in both PCl3 and PH3 we have to make constant P. So that means what? Here in the first compound P is equal to 22.57, chlorine is equal to 77.43. So ratio is equal to higher by smaller. So 77.13 divided by 22.57, that is equal to 3.43. In the second compound, similar way we get ratio of phosphorus to hydrogen as 91.18 is to 8.82, that is equal to 0.967. Ratio of these two of hydrogen chlorine, that is equal to 1 is to 35.47. In the second compound HCl, the ratio is coming as 1 is 35 is to 1. Since the ratio weight of hydrogen chlorine bear the same ratio, so the data agrees with the law of reciprocal proportion. Example 2. Copper sulfide contains 66.5% copper. Copper oxide contains 79.9% copper, and sulfur trioxide contains 40% sulfur. Show that the data agrees with the law of reciprocal proportion. Solution. In copper sulfide, percentage of copper is equal to 66.5 and percentage of sulfur is equal to 33.5%. So the 1 gram of copper combines with sulfur 33.5 divided by 66.5, that is equal to 0.5. In copper oxide, percentage of copper is equal to 79.9%. Percentage of oxygen is equal to 20.1%. So 1 gram of copper combines with oxygen 20.1 divided by 79.9 is equal to 0.25. Weight of the ratio of sulfur and oxygen, if we keep copper as constant, that is equal to 0.5 is to 0.25, that is equal to 2 is to 1. In sulfur trioxide, percentage of sulfur is equal to 40%, so percentage of oxygen is equal to 60%. So weight of sulfur and oxygen is equal to 40 is to 60 is equal to 2 is to 3. Ratio of weights of sulfur and oxygen bear a simple whole number ratio, that is equal to 2 is to 1 divided by 2 is to 3, that is equal to 3 is to 1. So the data agrees with the law of reciprocal proportion. Shortcut method. In copper sulfide, copper is equal to 66.5, so sulfur is equal to 33.5. So ratio of copper is to sulfur is equal to 0.5. In copper oxide, copper is equal to 80%, oxygen is equal to 20%, so ratio of copper is to oxygen is equal to 0.25. So the ratio of sulfur is to oxygen is equal to 0.5 is to 0.25, that is equal to 2 is to 1. And the third compound, sulfur trioxide, the percentage of sulfur is equal to 40% and percentage of oxygen is equal to 60%, that is equal to 2 is to 3. Since the weight of sulfur and oxygen bear a simple whole number ratio, so the data agrees with the law of reciprocal proportion. Example 3. Carbon dioxide contains 27.27% of carbon. Carbon disulfide contains 15.79% of carbon, and sulfur dioxide contains 50% of sulfur. Are these figures in agreement with the law of reciprocal proportion? Solution. Here we have carbon dioxide, carbon disulfide and sulfur dioxide. So from carbon dioxide and carbon disulfide, the carbon is common and we can get the ratio of sulfur and oxygen which is there in sulfur dioxide. So in the first compound, carbon dioxide, percentage of carbon is equal to 22.27%, percentage of oxygen is equal to 77.73%. 1 gram of carbon combines with oxygen is equal to 77.73 divided by 22.27. is equal to 2.66 gram. In carbon disulfide, percentage of carbon is equal to 15.79 percentage, percentage of sulfur is equal to 84.21 percentage. 1 gram of carbon combined with sulfur is equal to 84.21 divided by 15.79 is equal to 5.33 gram. So the ratio of weights of sulfur and oxygen is equal to 5.33 is to 2.66, that is equal to 2 is to 1. In sulfur dioxide, percentage of sulfur is equal to 50% and percent of oxygen is also equal to 50%. So the ratio of sulfur and oxygen in sulfur dioxide is equal to 1 is to 1. So the ratio weight of sulfur and oxygen be a simple whole number ratio, that is equal to 2 is to 1, that is equal to 2 is to 1 is to 1 is to 1, that is equal to 2 is to 1. So the data agrees with the law of reciprocal proportion. Shortcut method. In CO2, percentage of carbon is equal to 22.27, oxygen is equal to 77.73. So the ratio of carbon is to oxygen is equal to 0.66 gram. In CS2, percentage of carbon is equal to 15.79. So sulfur is equal to 84.21. The ratio of carbon is to sulfur is equal to 84.21, 15.79, that is equal to 5.33. So ratio of weight of sulfur and oxygen in both CS2 and CO2 is equal to 5.33 divided by 2.66, that is equal to 2 is to 1. In sulfur dioxide, the ratio is 1 is to 1. Since the ratio of weights of sulfur and oxygen bear a simple whole number ratio, so the data agrees with the law of reciprocal proportion. Example 4. Ammonia contains 82.35% of nitrogen and 17.65% of hydrogen. Water contains 88.9% of oxygen and 11.1% of hydrogen. Nitrogen trioxide contains 63.15% of oxygen and 36.85% of nitrogen. Show by calculations from these data which law of chemical combination is verified. So in ammonia, percent of nitrogen is equal to 82.35%. Percentage of hydrogen is equal to 17.65%. 1 gram of hydrogen combines with nitrogen 82.35 divided by 17.65, that is equal to 4.66 gram. In water, percentage of oxygen is equal to 88.9%. Percentage of hydrogen is equal to 11.1%. So 1 gram of hydrogen combines with oxygen is equal to 88.9 divided by 11.1, that is equal to 8 gram. So the ratio of weight of nitrogen and oxygen is equal to 4.66 divided by 8 is equal to 0.583 is to 1. In nitrogen trioxide, percentage of nitrogen is equal to 63.15 percentage. Percentage of oxygen is equal to 36.85 percentage. So ratio of nitrogen and oxygen is again 36.85 is to 63.15, that is equal to 0.583 is to 1. Since the ratio of nitrogen and oxygen bear the simple ratio or same ratio here, so the data agrees with the law of reciprocal proportion. Shortcut method. In ammonia, percentage of nitrogen and hydrogen we compare. So 1 gram hydrogen combines with nitrogen is equal to 82.35 divided by 17.66 is equal to 4.66 gram. And in water, we compare the weight of hydrogen, how much 1 gram of hydrogen combines with oxygen, that is equal to 8 gram. Then we compare the weight of nitrogen and oxygen in both the compounds, that is equal to 4.66 is to 8, that is equal to 0.5831. In nitrogen trioxide, nitrogen is equal to 63.15, oxygen is equal to 36.85. So the ratio of nitrogen is to oxygen is equal to 36.85 is to 63.15, that is equal to 0.5831. The ratio of weights of nitrogen and oxygen be a simple whole number ratio, so the data agrees with the law of reciprocal proportion. Example 5. In methane, every 12 gram of carbon is having 4 grams of hydrogen, while in carbon dioxide, 12 gram of carbon combines with 32 gram of oxygen. Water is having hydrogen and oxygen in 1:8 by ratio by mass. Show by calculations from this data that the law of reciprocal proportion is verified. Now here in methane, weight of carbon is equal to 12 gram and weight of hydrogen is equal to 4 gram. And in carbon dioxide, weight of carbon is equal to 12 gram and weight of oxygen is equal to 32 gram. So in both these two compounds, the ratio of weight of hydrogen and oxygen in methane and carbon dioxide, which combines with the fixed weight of carbon, that is equal to 4:32, that is equal to 1:8. And in water, the ratio of hydrogen and oxygen is equal to 1:8. Since the ratio of weights of hydrogen and oxygen bear is same ratio 1:1, so the data agrees with the law of reciprocal proportion. This question can be done by shortcut method also. At first we have to make 3 columns. In the first column we write methane, in the second we write carbon dioxide, in the third we write water. Here in case of methane we write 12:4, in case of carbon dioxide we write 12:32. Then we divide the number 4:32, it comes as 1:8, that is the ratio of hydrogen and oxygen if we keep the fixed amount of carbon in both the compounds of methane and carbon dioxide. And in water, the percentage, and in water the ratio is already 1:8. Since the weight of the hydrogen and oxygen bear the same ratio, so the data agrees with the law of reciprocal proportion. Fifth law, law of combining volumes, or Gay-Lussac's law of combining gases. This law states that whenever gases react, they do so in volumes which bear a simple whole number ratio to one another and to the volume of the gaseous products when all the volumes are measured at same temperature and pressure. Let's take some examples. One volume of hydrogen and one volume of chlorine combines to form 2 volumes of hydrogen chloride. Similarly, 2 volumes of hydrogen and 1 volume of oxygen will form water if the product is in the gaseous state. Numerical problems based on the law of combining volumes, or Gay-Lussac's law. What are the steps to be followed in solving problems based on Gay-Lussac's law? The steps are to be followed in solving problems based on Gay-Lussac's law are as: number 1, balance the chemical equations which are given. Number 2, the number of stoichiometric coefficient is taken as the volumes of the gases. For liquids and solid form, the volume is taken as 0, as the law is valid only for the gaseous products at same temperature pressure. What is a resulting mixture? The residual mixture of reactants and products left after the completion of a reaction in a closed container is known as residual mixture. Suppose in a flask 5 liters of hydrogen are present along with 2 liters of oxygen, and if the mixture is burned, then only 4 liters of hydrogen will combine with 2 liters of oxygen, leaving only 1 liters of hydrogen as residual mixture in the flask. The resulting mixture is what is left as residual mixture and as the products formed. Example 1. In the chlorination of ethane, quarter liter of ethane reacts with chlorine in the presence of sunlight to form trichloroethane. As per the equation, C2H6 plus 3Cl2 gives C2H3Cl3 plus 3HCl. Calculate the volume of chlorine required and trichloroethane thus formed. Solution. 1 volume of ethane requires chlorine is equal to 3 volume. So 250 milliliter of ethane will require chlorine 3 into 250, that is equal to 750 ml. Similarly, 1 volume of ethane forms trichloroethane as 1 volume. So 250 ml of ethane forms trichloroethane is equal to 250 ml. Shortcut method. First we write the equation. C2H6 plus 3Cl2 gives C2H3Cl3 plus 3HCl. C2H6 is 1, 3CHCl3 is equal to 3 volume, and C2H3Cl3 is also equal to 1 volume. So if 1 volume is 250, 3 volume is 750, and again 1 volume is again 250. In this way, the numericals of Gay-Lussac's law can be solved verbally. Example 2. 6 liters of ethene was burned in equal volume of oxygen at the room temperature. Writing the equation for the reaction, find the composition of the resulting mixture. Here, C2H4 plus 3O2 gives 2CO2 plus 2H2O plus heat. Now 1 volume of ethane requires 3 volume of oxygen, which gives 2 volume of carbon dioxide, and the water formed is at room temperature. 0 volumes is taken for water. Now 3 volumes of oxygen requires ethane, that is 1 volume. So 6 liters of oxygen is required by ethane is equal to 6 divided by 2, that 6 divided by 3, that is equal to 2 liters. So oxygen left, so methane left is how much? Ethane left is 6 minus 2 liters are used. So ethane left will be 4 liters. 3 volumes of oxygen forms carbon dioxide is equal to 2 volume. So 6 volumes of oxygen will form carbon dioxide 4 liters. So the resulting mixture will be carbon dioxide formed is equal to 4 liters and ethane left will be 4 liters. Oxygen left will be 0 because it is totally used up, and the oxygen formed will be again, and the water formed will be again 0 liters or negligible. In the equation, C2H4 plus 3O2 gives 2CO2 plus 2H2O plus heat. 6 liters of ethane is given and 6 liters of oxygen is also given. Now if 3 volumes of oxygen requires 1 volume, so 6 liters of oxygen will require only 2 volumes of ethane. So the amount of ethane left will be 6 minus 2, that is equal to 4 liters. Now oxygen is totally used up, and carbon dioxide is 2 volumes. So 6 volumes, 6 liters will give 4 liters. So carbon dioxide is given 4 liters. So the resulting mixture which is left is carbon dioxide formed is 4 liters, ethane left is equal to 4 liters, oxygen left is 0 liters because it's totally used up, and water formed is again negligible or 0 liters. Example 3. Ammonia was burned in oxygen in presence of platinum catalyst as per the equation. 4NH3 plus 5O2 gives 4NO2 plus 6H2O, gaseous state. If 2 liters ammonia was burned, find the amount of oxygen required and nitric oxide thus formed. So the equation is 4NH3, that means 4 volume, 5O2 means 5 volume, 4NO2 means 4 volume. Now we have 2 liters ammonia was burned. If the 4 liters ammonia requires oxygen is equal to 5 volume, 2 liters of ammonia will require oxygen 0.5 liters. So 4 volume ammonia forms nitric oxide is equal to 4 volume. So 2 liters ammonia will form nitric oxide is equal to 2 liters. Shortcut method. First we write the equation, and then below stoichiometric coefficients we write the volumes. 4 volumes in below ammonia, 5 volumes in below oxygen, and 4 volumes below nitric oxide. So ammonia is equal to 2 liters is given. So oxygen required is equal to 2.5 liters, half of it, and nitric oxide formed is also 2 liters. So in this way the equation can be solved verbally. Example 4. What volume of oxygen at STP is required for the complete combustion of 10 liters of ethane at 141 degrees centigrade and 1140 mmHg pressure? Solution. Complete combustion of ethane takes place as 2C2H6 plus 7O2 gives 4CO2 plus 6H2O, where 2 volumes of ethane require 7 volumes of oxygen. So 2 volumes of ethane requires oxygen is equal to 7 volumes. So we have 10 liters. So 10 liters of ethane will require oxygen 7 into 10 divided by 2, that is equal to 35 liters. Now at STP the volume can be calculated as volume 1 is equal to 35 liters, that we got it. V2 has to be calculated. P1 is equal to 1140 and P2 is equal to 760 and T1 is equal to 141 degrees centigrade given plus 273, that is equal to 414 Kelvin, and T2 is equal to 273 Kelvin. Now why? Because we have to calculate the volume of oxygen at STP. By combined gas law, P1 V1 by T1 is equal to P2 V2 by T2. On substituting the given values, we get V2 is equal to 52.5 liters. Example 5. When nitrous oxide reacts with methane, following reaction takes place in the gaseous state. 4N2O plus CH4 gives CO2 plus 2H2O plus 4N2. If all the gaseous volumes are measured at same temperature and pressure, calculate the volume of dinitrogen oxide or N2O and methane required to give 250 ml of steam. Now, according to the reaction, 2 volumes of steam or water is formed by N2O for volume. So 250 ml of water is formed by N2O is equal to 4 by 2 into 250, that is equal to 500 ml. So 2 volumes of water is formed by methane, 1 volume. So 250 ml of water is formed by methane is equal to 1 by 2 multiplied by 250, that is equal to 125 ml. Shortcut method. First we write the equation as 4N2O plus CH4 gives CO2 plus 2H2O plus 4N2. Now below N2O we write 4 volumes because stoichiometric coefficient is 4. Below methane we write 1 volume and below steam we write 2 volume. Now I have 250 milliliter of steam. So if 2 volume is 250 milliliter, then volume is 125 and 4 volume is 500. So in this way we can solve the equation verbally. Example 6. 1 volume of air containing 21% of oxygen by volume will be required to burn completely 21 ml each of methane and ethane at room temperature. Now here we have two equations. CH4 plus 2O2 gives CO2 plus 2H2O, where water is a liquid because it is measured at room temperature, and the another equation is 2C2H6 plus 7O2 gives 4CO2 plus 6H2O. There also water is in the form of liquid. Now in case of methane, 1 volume methane requires oxygen is equal to 2 volumes. So we have 21 milliliter each methane. So 21 ml of methane will require oxygen 42 ml. In case of ethane, 2 volumes of ethane requires oxygen 7 volume. So 21 ml of ethane will require oxygen 7 into 21 divided by 2, that is equal to 73.5 ml. So total amount of oxygen required for both the reactions are 73.5 ml plus 42 ml, that is equal to 115.5 ml. Let the volume of air required be x ml. Then 21% of x by 100 is equal to 115 ml. So solving for x is equal to 550 ml. So the volume of air required is 550 ml. Shortcut method. Here we write both the equation. So first, in case of methane it is 21 ml. So oxygen required is 2 volume, that is equal to 42. Then we add up in case of ethane, 21 ml requires oxygen 7 volume, or 2 volume is to 7. So 21 is to 7. We solve as per the relation. 21% air is oxygen. So 21%. So 21% of x is equal to 115.5 ml. Solving for x is equal to 550 ml. So in this way, the volume of oxygen required can be found out. Example 7. 4 liters of octane was burned with 5 liters of oxygen and the resultant mixture was cooled at room temperature. What is the volume and composition of resulting mixture? Solution. The equation is as 2C8H18 plus 25 O2 gives 16 CO2 plus 18 H2O. Now that means 2 volumes of octane reacts with 25 volumes of oxygen to give 16 volume of carbon dioxide, and the water becomes zero because it is measured at room temperature. So 25 volumes of oxygen is mixed with octane is equal to 2 volumes. So 5 liter oxygen is mixed with octane. 2 by 25 multiplied by 5 is equal to 0.4 liters. So octane left is equal to 4 liters minus 0.4, that is equal to 3.6 liters. Again, 25 volumes of oxygen gives carbon dioxide is equal to 16 volumes. Therefore, 5 liters of oxygen give carbon dioxide 16 divided by 25 multiplied by 5, that is equal to 3.2 liters. Resulting mixture octane left is equal to 3.6 liters, carbon dioxide formed is equal to 3.2 liters, and water formed is equal to 0 liters. Shortcut method. First we write the equation. 2C8H18 plus 25O2 gives 16CO2 plus 18H2O. Now just below octane we write 2 volumes, and the stoichiometric coefficient of oxygen is 25, so that means oxygen required is equal to 25 volumes, and the carbon dioxide formed is 16 volumes. After doing the calculation, we get octane used is equal to 0.4 liters and carbon dioxide formed is equal to 3.2 liters. Hope you have understood different laws of chemical combination and the method of solving problems based on it. Please like, comment and share this video. Subscribe to the channel Partha's World for more such videos. Thank you.